Hi guys, I'm back with the Westinghouse radio I was restoring before I got a little bit sidetracked with the Motorola radio. Now, let me just give you a short recap. Aside from the main electrolytic capacitor, which was mounted here, all the other parts, or well, except perhaps for a few resistors, have been replaced. And I did try, as you can remember in one of the previous episodes, to make the Westinghouse work by slowly powering it up with the Variac. Now, unfortunately, the only thing I got out of the radio was a very slight buzz from the speaker. And as I started measuring certain points on the radio, I found out that the voltages were incredibly off from the voltages that really need to be present on this chassis. So what I'm going to do now is continue measuring all the voltages that are marked on the schematic and try to pinpoint where the origin of the problem lies. Okay, this is a status update. What I did to the chassis was I changed the original AC cable because the old one was simply not reliable anymore. It turned out that it was full of short circuits, or well, I should say not short circuits, but rather bad conductivity. So I ended up cutting it away and replacing it by, at least temporarily, a modern one, as you can see, which works a lot better. Also, if you take a look at this part, this one here, originally where you see this little contact board and this diode, there was located a selenium rectifier. Now, I unmounted the selenium rectifier already quite a while ago, and I replaced it by this silicium rectifier. Now, according to the schematic, which I have here, according to the schematic, I don't know if you can see this, but if you look closely here, you see there is a capacitor in parallel with the diode. Now, I think the exact term for such a setup is a snubber circuit, or well, the capacitor is really a snubber capacitor, you could say, which means that the intent of the capacitor is that when you switch on the current that goes through the radio, you get a surge, and that capacitor is meant to slow down a little bit the surge current that goes through the rectifier. Now, when I measured it with the capacitor, which is or was a 10 nanofarad, which you see here, this is a replacement one, I couldn't get exactly the voltage that was written on the schematic, which is that if you measure the voltage at the exit of the diode, or rather at the cathode of the diode, you should get about 100 volts. well, exactly 100 volts if you read the schematic. And I simply didn't get that at all. Once I removed the snubber capacitor, the voltage became correct within 1 or 2 volts. I think I read out 103 volts. Yes, 103 volts. So that's okay. So that's, you could say, an improvement. Now, the thing is this. When I leave the radio on for a bit longer than, roughly speaking, a minute, this resistor here, which is encapsulated in a sort of heat resistant cover, I think it's mica, well, this resistor, which is a flexible resistor of 150 ohms, 1 watt, gets incredibly hot. And I mean really, really hot. Even that hot that it started smoking a little bit. Now, after a while the smoke abated, so I guess the surface of the resistor must have been soiled a little bit. But nonetheless, it becomes really hot. But I guess it's not abnormal, since they covered it by design with this mica sleeve. Just in case, I think, to reduce the heat radiation, so to speak, from this resistor. Now, the point is this. For a while, the filaments of the tubes, which I took out of the radio, glowed. They glowed rather normally, I would say, but now again they don't glow. So I'm not sure what's going on with this within the circuit. So what I'm going to do next is investigate two things. One, is there a short circuit close to the cathode of the rectifier, which makes the resistor run very hot? Yes or no? Probably not. Why do the filaments of the tubes glow, but only intermittently? So I'm going to check the tubes just in case to see whether they are still functioning or not. I think they will be functioning, but anyway, I will check them just to make sure. And what I'll do next is start measuring voltages downstream from the output of the rectifier. So we already know that at the output itself of the rectifier we have 103 volts, which according to the schematic is pretty close to what it should be. So next I'm going to go down the whole circuit and see whether I can find faults or any other sort of problem downstream from it. Also, there is one detail which bothers me a little bit, and that's this resistor here, this one. Now, this resistor, I don't know its exact value, but it's really very discolored. And according to the schematic, I think it should be a 2000 ohms resistor. Which is, although no, the 2000 ohms resistor might be the canned ohm. So let's see. It might actually, well, it could be either 820 ohms. It could be an 820 ohms or a 1000 ohms resistor. But in any case, whichever it is, as you can see, it's quite discolored, and the surface looks like it melted a little bit. So I suspect this resistor must have been, at one time or another, extremely hot. And since it's a carbon type resistor, the chances are it burned through, or at least its value isn't what it should be anymore. So there we are. I checked up everything until the flexible resistor. So now I will move on through the whole circuit. The resistor you see here, this one over here, which is an 820 ohms resistor, nearly fried because of a short circuit. And the short circuit was down here, where a lead which comes from the positive, this red one here, passed along a negative wire with, well, this blue wire which conducts negative voltage. So in effect there was a live shortage just here at this pin of the tube, which is located here. So the short circuit was in the process of frying up this resistor. Now I measured it out, it's still good, but I'm going to change it for a metal oxide of the same wattage, a modern one. Also, I removed one of the capacitors. In fact, this small one replaces the big one that was here before, because I suspect the capacitor was, well, because of the short circuit, was fried up too. Anyway, the one I replaced felt warm to the touch while there was power on the radio chassis. So I replaced that too. Believe it or not, I got some life out of the Westinghouse. In fact, it's nothing more than buzzing. A rather bad buzzing when I touch certain parts of the radio. And it also has a bad case of microphonics. As you can hear. So that will have to be tackled. So the volume works. I mean, you can hear the TV on the background, but as you can hear, the sound is rather loud if I touch certain parts of the radio. So what I'm going to try now is to see whether I can elicit some life out of the radio by tuning the alignment coils. I doubt it, but the microphonics are peculiar. I'm tuning the radio, or rather I'm trying to tune the radio. But all I can hear are the microphonics through the 1U5 at the bottom. I don't think I'm going to get a lot of music or anything out of the radio, but I mean, I changed all the parts, or nearly all the parts in the radio, so it must be really badly aligned. So let me see whether I can get a little bit of life out of it. But I would say no. So it's too early yet to cry victory. So, okay, to wrap it up for tonight, what did I do? Well, last time I told you that I took out the snubber capacitor, which was placed parallel with the rectifier. In fact, the new 1N4007 rectifier diode, which I used instead of the selenium. And that sort of helped to bring the voltage up to a normal level. What I then did was I replaced the 220, the AC cable, by a new model. And I also changed a capacitor, an electrolytic capacitor, and I also changed the fuse, which was in the fuse holder, because the one which was inside originally didn't measure out so well. It measured out intermittent. So I replaced it by a much more reliable fuse. I also went over the whole circuit to check whether there were any obvious faults or anything, short circuits and all that. I think I got all the short circuits and errors out of it. I also measured the voltages. Now, the filament voltages are, I wouldn't say spot on, but give or take 0.2 volts. It's near the voltage it should be. However, certain voltages are either way too high or way too low. For example, on the 1R5, which is the tube up here, one pin should measure, and more specifically pin 4 should measure minus 10 volts, and I measured minus 8.7, for example. Pin 3 should measure 40, and I measure 53.1, which is too high. Pin 2, which is another grid, should measure 85, and it measures 96 volts. So obviously there's still some work to do about the voltages which are being pumped through the radio chassis. Now, one thing I can say for sure, that is at the amplification stage, which is this tube, the 3V4 you see here, works perfectly, because I can lower or raise the volume and it works perfectly. So the amplification stage is okay. The microphonics in the 1U5, well, I don't know, maybe that's typical for this type of radio, but it's not good, so I will have to fix that. Also, well, as you can hear, the microphonics are loudest on the 1U5. Maybe the tube is defectuous, I don't know. Defective, I mean. So I might have to look for another tube. But like I said, it's quite hard to find good tubes. Anyway, that's where I stand tonight. What I'm going to try to do is to check tomorrow or later in the week why certain voltages are either too high or too low. So, you know, changing all those parts in the radio makes me think that maybe certain values I used were too far off to make a good repair. I don't know. I will have to see whether it's the parts I used, so the parts I replaced, that give me the trouble, or it's simply a bad circuit somewhere. It might be that the capacitor network, which I rebuilt and you see here, is also defective, or simply I made an error building it. So it's obviously also very, very sensitive to outside influences. So I don't know if that's normal, but since I took out the old capacitor network, there's no way I can check that to see whether that's normal, the sensitivity, or not. In any case, tuning the radio doesn't bring any sort of noise, I mean intelligible noise, out of the speaker. So let's say roughly we're halfway to finding a solution to the problem, but we're not there yet.